Welcome, everybody. Nice to meet you. I'm Mark Scanlon with Atlantium. Just to tell you a little bit about myself, I've been in the UV business since 1993. I've worked for all of Atlantium's major competitors. I've treated everything from wastewater all the way up to ultra pure. I live in Columbus, Ohio in the US. I've been married to a wonderful woman for almost 43 years. I have 4 adult children and 7 grandchildren, and we are absolutely thrilled that you're joining us today for this sugar syrup seminar. Let's begin if we can. So today, our agenda is as follows. We're going to talk a little bit about the terminology of UV treatment. We're going to show you simple syrup protection methods. We're going to show you a widely different and distinct approach to simple syrup protection. We'll follow that up with a case study, and then, of course, we'll make time for questions and answers. Atlantium is a leader in the food and beverage market, has been since the inception of the company way back in 2003, so that's going on 20 years. We have thousands of installations, customers all over the world in more than 65 countries, and we work under the strictest regulatory requirements. Some of the regulatory requirements you can see on your screen, such as US EPA, NSF, ISO, we are committed to complying with all the regulatory authorities wherever they are in the world. As you can see, we have sales offices on all the continents, and our headquarters and factory are located in Israel. As I said, we serve the food and beverage industry globally. These are the market segments that we do serve, anything from soft drinks to juices, bottled water, dairies, breweries. All of these industries, to some extent, use sugar syrup and need sugar syrup protection. So we wanted to illustrate the breadth and width of these companies. So let's talk a little bit about the terminology of UV treatment. All right. Some of this might be a refresher for those who know UV. Others might be not aware, so we want to make sure that you have a firm and complete understanding of this. So, basic terminology. First, we're going to talk about UV dose. UV dose is the single biggest determinant as to whether your UV unit is going to work. And UV dose is the amount of light energy that the microorganism was exposed to crossing the reactor. Typically, this dose is measured in millijoules per centimeter squared. UVT, which is another important parameter, UVT stands for UV transmittance. It is the amount of light that passes through 1 centimeter square of water. So we have the intensity of the lamp on the chart below going through a 1 centimeter square test cuvette, and then we measure the amount of UV absorbance, how much of that water or how much of that fluid the UV passes through and how much gets absorbed by contaminants. Now, contaminants can be anything from dissolved organics to dissolved metals, color, suspended solids, dissolved solids. All those factor into what the UV transmittance is. And you'll see how important that is as we go forward. Fundamentals. What does UV do? How does it work? UV inactivates cells by damaging their DNA. They can't reproduce, they can't infect. So therefore, you have a whole dead microorganism in your solution. Now, conventional UV puts out at 254 nanometers light, all right? That 254 nanometer light inhibits DNA replication. That has been what the industry has used for probably the last 50 years. With our type of lamp from Atlantium, it's called a medium pressure lamp. We'll talk more about medium pressure in just a moment. It puts out a polychromatic light. So it's a broad spectrum output. What we have found in our work with these types of lamps is that most folks think 254 is the peak germicidal wavelength, when in actuality, it is more like 265 nanometer. Again, the 254 and 265 nanometer wavelengths are below that of visible light. In addition, the style of lamps that Atlantium uses, which are proprietary, by the way, they disable repair mechanisms in microorganisms. Believe it or not, some microorganisms have an enzyme that is activated when they do not receive a proper dose. What does that mean? It means that if the organism has not received a proper dose and the enzyme is activated, then downstream the enzyme will repair the DNA damage and the microorganism will begin to start growing again post the UV unit. Now, the way the actual mechanism works to inactivate a microorganism is shown on the right of your screen. You see where it says dimer and UV light? There's a thymine dimer that the UV light actually fuses together. The microorganism cannot finish replication, so it dies. Any microorganism can be inactivated using UV. If you're familiar with UV, this is a refresher for you. If not, at least you have a rudimentary understanding of how UV works for inactivation of any microorganism. So let's look at microorganisms in their relative size. On the left, you'll see adenovirus at 100 angstroms. In the middle, you'll see E. coli, lactobacillus, Saccharomyces, like a brewer's yeast. On the right, you'll see Giardia, which is a protozoa, or its evil brother, Cryptosporidium. They're both 10 micron. The difference is some of these organisms are more prevalent than others. Adenovirus is probably the most common virus we see in municipal and well water systems across the United States. The idea is any microorganism can be inactivated using UV. Now, as I cited in the previous slide, there's no repair effect using the style of lamps that we use. MP means medium pressure. We're talking about the gas pressure inside the lamp. We'll talk a little bit more about that in just a moment. This is a citation from a study that was done in 2002 by a university over in Japan. And it says the emissions of the medium pressure UV lamp wavelengths from 220 to 300 nanometers were found to reduce the subsequent photo repair of the dimers. And so therefore, any microorganism won't have that ability to repair itself using the proper medium pressure lamp, such as Atlantium has. Now, this shows you the actual spectral output of the medium pressure lamp. When we talk about medium pressure and low pressure, we're talking about the gas pressure inside the lamp. Depending upon how the lamp is constructed and how it's built, will affect the spectral output as well as the watt rating of the lamp. So as you can see there, it goes anywhere from 200 all the way up to 400 nanometers. You'll notice that the peak, you'll see a peak around 265. That again is near the peak germicidal wavelength. Okay. Now, just to show you the difference in lamps, low pressure versus medium pressure. And again, we're talking about the gas pressure inside the lamp, not hydraulics. The medium pressure lamp has broader wavelengths, as you just saw. It's 30 to 40 times more intense in its output than conventional low pressure lamps. So therefore, you need less of them to get the same effect. It's not sensitive to water temperature. There's no repair effect on the microbes. And you can actually vary the output of the medium pressure lamp based on operating parameters. The lamp is surrounded by a quartz sleeve or a quartz tube. You'll notice that there's two different thicknesses of these quartz tube. Conventional UV reactors use the quartz tube on the left. Atlantium uses the one on the right. I would submit to you there's several key differences. One is the thickness, and the other is the length. The short, fat quartz sleeve on the right is very robust, and in terms of replacing it, very seldom does it have to be replaced on a periodic basis. Once it's in there, it stays in there for a very long period of time. It doesn't break very easily, unlike the quartz sleeve on the left. Okay? And that shows you the differences in the length. Now let's talk about effective temperature on UV output. All right, again, you have a lamp inside of a quartz sleeve. In between the surface of the lamp and the inside of the quartz sleeve, there's an air gap. That air gap is subject to the prevailing temperature of the fluid going around the quartz sleeve. Now, if that fluid is very cold or very hot, what happens is that on a conventional UV lamp, that lamp is either cooled too much or heated too much. And when that happens, unfortunately, the lamp output drops, either too cold or too hot. With the style of lamp that Atlantium uses, it's linear. We don't have any drop off no matter what temperature the fluid is going around the quartz sleeve in our reactors. All right, the reason is because the skin temperature on our medium pressure proprietary lamp is about 600 degrees C. So it burns rather hot. Doesn't matter how cold, how hot, it will stay. You won't have any drop off based on temperature of the fluid going through the reactor. All right, so that ends our quick little UV 101 primer. Let's talk about simple syrup protection methods. Okay. The most common method has been pasteurization. This has been done for decades. The benefits of pasteurization, it's been very effective at controlling microorganism growth. However, we have seen in later years, because the organisms have mutated, that the effectiveness of using heat to control microorganism growth has begun to be limited. It is readily available. There's pasteurizers and manufacturers worldwide. It has been a proven method, as I said, for decades. And it is easy to integrate into your overall process. People have understood pasteurization for years and years. Now, what are some of the drawbacks of pasteurization? It does have a very high energy usage, and an associated carbon footprint is quite large based on the energy consumption. Right? When you have to heat up fluid or water and hold it there for an extended period of time, that is a big energy drain. Secondly, they're not easy to install. They do occupy a large space footprint within a facility. And when you have to dedicate that space to using pasteurizers, then that takes away from production space you might be able to use for, let's say, an additional line. Finally, there's operational complexity. You have to wait for the pasteurizer to get up to temperature. You also have to, if you're suffering from microbial growth, you have to pasteurize for even a longer duration. And all those play into the cost of operation for using these pasteurizers. Another big drawback, especially when it comes to sugar syrup, has to do with caramelization. And especially if there's a lot of start-stop operation, the caramelization frequency increases, then the flow rate stops and you have to find ways to eliminate the caramelization by using hot water or steam or mechanical cleaning. And in addition, the caramelization and associated reactions can alter the color and aromas of liquid sugar. Okay. Now, we think Atlantium says that UV offers all these benefits without any of the drawbacks. So let's get into the specifics if we can. So what we have seen in the market as far as the use of pasteurizers over various market segments is that there is a trend to replace pasteurization with alternative technologies. Now, Atlantium has vast experience in replacing pasteurizers in other applications in the food and beverage industry. We were the pioneer to do it for dairies to meet the pasteurized milk ordinance. And in that case, we treat water to meet the pasteurized milk ordinance. And the way the regulators look at this, they look at this as if the water that is UV treated by Atlantium is the same as if it went through a pasteurizer. So they call it pasteurized equivalent water or product contact water as if it was pasteurized. But not just any UV will do the job, even when it comes to sugar syrup. We're going to show you some specific benefits as far as using Atlantium is concerned. All right. We talked about low UVT and what UVT is, low UV transmittance. When you have low transmittance sugar syrup, it makes conventional UV less effective, and the bugs become more resistant. So in a conventional low pressure UV reactor for sugar syrup, the output of the lamp intensity is insufficient to treat the low UVT. You don't get the required 4 log 99.99% removal. And low pressure, if you want to run your sugar syrup at an elevated temperature, you're going to see a drop off because of the temperature of the sugar syrup going through the reactor, as we showed. So it's not suitable for high temperature sugar syrup treatment. Conventional medium pressure might cause overheating and lead to caramelization, which stops the production and can affect taste and odor. So here are the challenges when it comes to protecting your sugar syrup. There are 3 aspects of this: disinfection, high Brix levels, and low UVT. On disinfection, we're looking at thermophilic acidophilic bacteria, TAB, which are spoilage organisms. They are a nettlesome problem. They can generate strong off flavors due to guaiacol or bromophenol production. And the key factor is, as we talked about, these organisms have mutated. They've become resistant to pasteurization. So even if you prolong the pasteurization cycle and you run at a higher temperature and you run at a longer duration, all the microorganisms do is say, we like this additional heat, we like this additional time that we're under heat, and we're going to keep growing regardless. Now, the center slide talks about high Brix level. Brix, of course, is the sugar content of an aqueous solution. 1 degree Brix is 1 gram of sucrose in 100 grams of solution and represents the strength of the solution as a percentage by mass. So even if you have high Brix levels, depending upon the UV reactor that you have, this is a challenge. You have to make sure that the reactor design takes into account Brix levels that can fluctuate based on the sugar syrup source how it's stored, seasonal variations, etc. The other aspect of sugar syrup is low UVT. Some sugar syrups have UV transmittance of 15%. That means only 15% of the UV gets through and 85% gets absorbed by contaminants. It doesn't mean if you have a low UVT of 15%, you cannot use UV. You just have to size the unit to accommodate the lower UVT values. And again, these UVT values will fluctuate based on seasonal variations, the source of the sugar syrup. Is it sugar cane? Is it sugar beet? What kind of storage, etc., that the sugar syrup has? Does it come in a tanker? All these factors come into the aspect of UVT. Now, medium pressure lamps are not enough to ensure protection and performance. There's more to this than meets the eye. We have a special solution for sugar syrup protection, and we are distinctly different, and it simply works. And we'll show you why and how. Now, these are typical sugar syrup units from other UV manufacturers. I want to point out several things about these individual reactors. Notice that the configuration on all four of those in terms of inlet outlet, they're on the top of the reactor. Why is that important? Because this reactor design has been used for decades in the UV industry. And unfortunately, when you look at the computational flow dynamics of how the syrup travels through these systems, you will see areas where there are areas of non-treatment. For instance, on the chamber on the bottom left, you see a multiple lamp system. What happens when one of those or more of those lamps don't work? You have a possible area of non-treatment. In any case, in all of these reactor types, they are susceptible to vortices and eddies, and you do not get a uniform dose distribution throughout these reactors because of the inherent deficiencies of the reactor design. So that's what has been common and used in the industry for years and years. Here is our solution. It's the RCM 200 series. It is distinctly different, and it looks like that. One of the things you'll notice right away, it is a vertical configuration. You feed the sugar syrup from the bottom, and it comes out the top. Okay, this assures that the reactor is continuously filled all the time with syrup, and you have excellent flow-through capabilities. So with a vertical footprint like this, it shaves down the amount of space that is needed. With this type of reactor design, there are no dead areas of disinfection. There's no short circuiting through this reactor. You can be assured that every drop of sugar syrup that goes through there gets a uniform dose distribution. Okay? So it simply works, and it simply works because Atlantium ensures an accurate UV dose. Now, how do we do that? It's not easy to measure UV dose. There's no one parameter that will give you UV dose. No single sensor can measure and monitor the UV dose. So what is UV dose? It is comprised of UV transmittance, flow rate, and lamp output. What Atlantium does is take all three of those signals, put it into a proprietary algorithm, and tell you what your real-time dose is all the time using the RCM series. All right. Now let's see how dose is affected by these various operating parameters: UVT, flow rate, and lamp output. So the idea is you always want to exceed the minimum threshold dose for the application. So if the UVT drops, the sugar syrup quality drops, and nothing else changes, everything else stays the same, your UV dose is going to drop, okay? The next scenario, if the flow rate drops and nothing else changes, your UV dose is going to go up. Third scenario, if the lamp output drops, the UV dose is going to go down, everything else being the same. Another scenario, if the flow rate increases and nothing else changes, the UV dose drops. So I'm trying to show this because our unit automatically, the RCM series unit from Atlantium automatically responds to changes in the flow rate, changes in the sugar syrup quality, and as the lamp ages, so that our goal is to always exceed the minimum threshold dose requirement for the application. We'll finish this in just a second. So if your flow rate goes up and your lamp output goes up, your UV dose can drop. If the UVT goes up and the UV dose goes up, in actuality, what will happen is that your lamp output will drop. The beauty about the RCM series from Atlantium is we do want to make sure that you get the proper dose, but we don't want to necessarily overdose. We want to make sure that we mitigate overdosing by responding to the operating conditions on a real-time basis. Now, the beauty about using Atlantium, it is the Atlantium RCM series, is that it is the only third-party validated UV solution for syrup. All right. What we looked at is, in terms of validating this unit, we actually introduced live organisms and put them through the reactor and then actually measured the log reduction of these organisms. Now, the setup was a 65 brick syrup. The spore's final concentration is 105 CFU per liter. On the screen below that, you see the actual flow schematic between a syrup that was spiked with organisms going through the UV system and then a sampling bottle. The results and conclusion are on the lower right of your screen. I want to point out the circled aspect, and this is from the third-party validation company that did this. The UV system may give a disinfection of greater than a 5 log reduction value. It complies with the acceptance terms of greater than a 4 log reduction value parameter. We're very proud of that. Oh, sorry, let me get past this. Okay, it's distinctly different and it simply works. Let's point out some of the features that we see on the RCM series. Okay, we have dedicated lamp output sensors. Each lamp has its own lamp output monitor. And at the same time you monitor the output, we also tell you the hours run on the lamps. So you always know what's going on with the lamps that are putting out the UV for the reactor. Secondly, we have 2 integrated UV transmittance sensors that tell you the quality of the sugar syrup going through the reactor. This is important in terms of doses we showed. Thirdly, we have special medium pressure lamps that are designed to eliminate disinfection byproducts. We do have a very unique chamber design. The idea is we want to have a thin annulus between the surface of the quartz sleeve and the inside of the reactor chamber so that we can get maximum penetration of UV light and get a higher dose from the UV light. So we make that annulus very, very thin. We also have what I think is one of the best features about this reactor design. We have a heat dispersion system. Why do we need that? If you have a lot of start-stop operations on your sugar syrup, we don't want to have a situation where the sugar syrup will caramelize. This heat dispersion system mitigates any opportunity for caramelization within the RCM reactor. So these are the key features to ensure performance. We'll talk about each one just briefly. So by having dedicated lamp output sensors, it gives us very precise dose control, right? And also it assures you that you only replace the lamps when they're needed. Because we know how many hours are on the lamp and we understand the dose requirement, we can correlate those two, and you can actually program the controller to notify you when a lamp needs to be changed. The integrated UVT sensors are probably one of the best features about this unit. It gives us reliable UV transmittance monitoring. UV transmittance is a great tool to use to determine the quality of your sugar syrups or the quality of your water, because it will tell you things that other types of measurements such as turbidity or conductivity will not. The benefit of using these UVT sensors, it enables us to always be able to deliver the precise dose for the application under the current operating parameters. With the type of lamps that we use that are proprietary, they enable disinfection without creating byproducts that can cause off flavors, etc. This shows you in detail the reactor design and how you have a uniform flow all the way through the reactor. The goal is to make sure we have a uniform dose distribution, no matter what path part of that sugar syrup flows through the reactor. It does give us the ability to assure you of 100% disinfection, even at relatively low UV transmittances, while always making sure we deliver the minimum dose required. And this is the heat dispersion system, and it prevents the overheating of the syrup and caramelization. The controller, I want to spend a little bit of time on the controller because it is user-friendly. This monitors and displays all the mission critical parameters. Below the box, you can see UV lamp intensity, UVT, flow rate, actual dose. I know it's small, but that number there is 200. That's saying that you're getting a 200 millijoule dose. The boxes below that show the lamp intensity, UVT, and flow rate. The other nice thing about this controller is that it monitors all these signals and actually has the capability on board to store all this continuous amount of data for up to 6 months. So if you want to know what happened to your UV system treating your liquid, your sucrose, you can go back and look at the logs and look at the data, pull up the reports, and have a very accurate summary of the operating performance of your RCM system. So it simply works around the world. We've had customers from such as Carlsberg in Denmark, Burner Food and Beverages in the US, other folks in Taiwan and more use the sugar syrup RCM series approach. The case study was done in Taiwan. This is a 55-year-old company. It provides soft drinks, edible oils, other types of ingredients. The project objective was to replace heat pasteurization with a UV disinfection process. So this shows you the actual system that's installed, again, being fed from the bottom, coming out the top. So these were the challenges that the company in Taiwan faced. Okay. Performance concerns. There was contamination of Bacillus subtilis to gram-positive rod-shaped bacterium. It's very heat resistant. It's a spore former, and the spores are quite hardy. Secondly, there was resistance to pasteurization from the thermophilic acidophilic bacteria, the TAB. Those have mutated so much that they've become highly resistant to pasteurization. They also suffered when running their pasteurizer through numerous incidents of caramelization where things got plugged up. In terms of the CapEx, the capital expenditure, pasteurization does require a large footprint. It was 3 to 4 times the amount of space needed versus the Atlantium RCM series. From an operating expense, OpEx perspective, again, it used a lot of energy, and energy has only gone higher based on what's happening in the world today. It did take time to heat, so this was time while they're waiting for the pasteurizer to get up to speed. That's time they can't use for production. So the solution was using the Atlantium RCM series. Now, in the lab tests, they use special medium pressure lamps from Atlantium. They selected those so that they had no issue of any kind of byproduct formation. This is what they indicated to Atlantium. No other component appeared in the chromatograms except trace amounts of monosugars. Number 2, the third-party validation. It was third-party verified to have a superior performance. Again, they actually ran live organisms through our unit to test. Finally, the results. The company in Taiwan indicated we did an outstanding job. They used this from June 2022 to March of 2023. And the performance, it was completely successful. All microbial tests during the 9 months of the operation met the required log reduction targets. And in terms of maintenance, again, using it continuously for 9 months, no caramelization. The amount of cleaning that they had to do on the unit was minimal. When they did, they had a CIP procedure that they engaged every 2 to 3 weeks, only with hot water. That was all. No kind of chemical cleaners such as caustic or acidic-based cleaners were used. In terms of support and service, one of the things I want to talk about at Atlantium is their dedication to supplying you with a unit that works. How do we do that? I've been in the UV business for almost 30 years. All right, so I know how to size units. I understand the applications. I've been in a lot of different industries and I understand the requirements. However, that being said, before Atlantium would accept an order, each order is vetted by an internal application engineer that goes over all the parameters to make sure that the unit that is ordered is going to work within the specified operating parameters. So we pride ourselves on that. We guard our reputation jealously, and we always have another set of eyes to look at this. Secondly, when it comes to support and service, we always quote, in most cases, the commissioning and startup and operator training. We have groups of technicians around the world, and we feel very strongly that it is an important aspect of this. When you buy a unit from Atlantium, we just don't sell you a unit and walk away. We offer spare parts support. We offer technical support. When our technician comes on site to start up and commission your Atlantium unit, We want to make sure that it's installed properly. So even before he comes on site, we will offer a pre-commissioning checklist and an installation primer so that whoever installs this particular unit understands that it has to be installed within a right set of parameters so it will operate effectively. The key benefits. We offer exceptional syrup protection, routinely getting 5-log reduction. We offer 100% syrup disinfection. By treating your sugar syrup with the Atlantium RCM series, you can get extended shelf life. In addition, there's ongoing reliable performance. This system and reactor was designed specifically for sugar syrup. It does have a small footprint. We offer you all the smart monitoring controls, so you monitor all the operating parameters on a continuous basis. And we offer superior power efficiency with our unit. So with that, I'm going to ask if there's any kind of questions. I see there's 6 questions in the Q&A. So let's read the first one. Why do European food and drink safety agencies not allow juices to be canned using only your technology? It has been checked by the Bulgarian Food Safety Agency as well as by a juice producer in the Swiss Confederation. Thanks in advance. Well, the short answer is every regulatory agency has their own criteria for acceptance, and Atlantium will work with the country regulators to offer the efficacy standards for this. Unfortunately, every country operates differently, and there are different requirements from the US versus the European aspect. But Atlantium is committed to working with these regulatory agencies to achieve acceptance. Let's look at the second one. How much will I save per hour of, Michael said it was a very impressive presentation. Thank you very much. How much will I save per hour of production per ton of product produced? Can we anyway calculate this? The answer is, yeah, you can, but the way to do this is it's case specific. Once you furnish what your operating parameters are, then we can turn around and do an ROI calculation. What bricks levels can be used? The bricks levels can vary. It all comes down to not so much the bricks levels, but what the minimum UV transmittance value is. I think our floor is probably somewhere around 15% UVT. Next question. Oskin says, for about caramelization, the main solution to use new kind of UV lamp of using this new kind of heat reducer. Is there any improvement about the UV lamp as well? The short answer is the lamp is proprietary. So what we need to do is take this type of lamp and make sure that, hold on, I want to make sure I understand the question, sorry. Yeah, in terms of improvement of the UV lamp, yes, there is an improvement in the UV lamp simply because of the style of lamp and the broad spectrum output. All right, it is a medium pressure lamp, and by using the heat dispersion system, the lamp itself will reduce disinfection byproducts because of the output of the wavelengths. All right. So there is improvement both in the lamp and the heat dissipation device. Another question, what is the recommended CIP process for this system? Excellent question. Typically, that's going to depend on your operation. If you're using hot water to CIP, you can do that whatever frequency works for you. Sometimes it can be as little as 2 or 3 weeks. Others, it could be longer. It all depends on the specific operating parameters in your plant. Okay, another question is, what is the standard inlet-outlet pipe diameter in fitting? Okay, the unit is equipped with, I'm going to use American nomenclature here, but it's 4-inch diameter tri-clamp fitting. Now we can do a DIN, etc. You also have the ability to use tri-clamp reducers and enlargers if you have pipe diameters that are smaller than that or larger than that. But the standard is 4-inch diameter fitting. Another question is, how do I send a sample? Great question. Typically, what we like to do on samples is get like a 100 ml sample. You put it in a plastic bottle, seal the cap, send it to your Atlantium representative in your particular region and locality. Then what will happen is we take that sample, put it in a UV spectrophotometer, and measure the UVT. And that's how we would do that. Second, another question from Marcio, minimum and maximum flow. The minimum flow probably is going to be about 1 or 2 meters cubed, probably 2 meters cubed. The maximum flow depends on what is your requirement. We're not limited so much by maximum as we are by minimum. How high and Amandeep says, how high the flow rate the system can handle at 67, 68 bricks. I'm going to say my probably around 20 meters cubed, maybe 30 meters cubed. It all depends on what the UVT level is. You know, 67, 68% brick syrup can vary widely in terms of the UV transmittance based on the the type of sugar syrup, the season, how it was processed, etc. All those come into play. Okay, Thanasis says, there is serious concern regarding these UV treatment byproducts. How can they be avoided by the special lamps of the system? What happens is the UV byproducts are a function of the spectral output. Depending upon what the requirements are in your locality, we can tweak these lamps. All right. The Amandeep says, great presentation. Can you share this presentation with all the attendees? Of course, we can do that. This is actually being recorded. We can send it out to all the attendees. You'll get an email concerning that. All right, Nagendra wants to know, what is the life of the UV lamp? Typically, if you're running the light on a continuous basis, you'll get about 4,000 hours, which is about 6 months. Next question from Justin. Any flavor change after the UV process? My understanding is that there weren't any flavor changes. The whole idea is we don't want to have any kind of off flavors, off odors, anything along that particular line. So there was no changes overall in terms of the quality. Finally, advancements with any Colombian companies, and what about FDA status on the technology? I will have to get back to you on whether we've done anything in Colombia. And in terms of FDA status, we're in compliance with the FDA. Okay, any other questions? All right. I want to thank everyone for their time and attention. I greatly appreciate the opportunity to bring this to you. I am always open to questions or anything like that after the seminar is over. And we want to do that. Oh, some more questions just popped up. Okay, Justin says, while starting the UV system, it takes about 1 minute to break in. At this period of time, is it possible to burn the syrup? Well, the answer is, what you can do from a programming standpoint is have a way to divert that if there would be any question about breaking in the syrup. And as far as sending the Q&A and also the participants, we certainly can send that information. Yeah, I understand, Justin, since the syrup is not moving at that time. Correct. So what will have to happen is that in order, it's a matter of programming, how the operating system is set up. So what you might want to do is have the system, you might want to have the sugar syrup flowing through the reactor, okay, as it's flowing, so you don't have a no-flow situation where you have that. Okay? Any other questions I may answer for you folks? Okay. Well, again, I want to thank everyone. Atlantium always stands ready to help each and every one of you with your individual questions. We have dedicated representatives around the world, and we look forward to exploring the opportunities of using the RCM series for sugar syrup. Have a great day, everyone.